All right, practice makes perfect, so let's work through some more trigonometric equation questions. So I'm just going to increase the difficulty a little bit more here. And I'm going to give you the following equation. It might look a bit weird at first. So this is going to be sine squared theta minus sine theta equals 0. Okay. Now that's a bit of a weird one if you haven't seen it before. Well, the idea is just to factor out sine. I'll just tell you what to do rather than faffing around for a long time discussing the various strategies. This is the strategy you use. Now, some people will divide by sine here, which is incorrect because what can happen is that sine could be 0, and you're not supposed to divide by 0 in maths. I don't know if you've ever tried to do that, but usually it doesn't work out well if you try to do that. Sine theta could be 0, so we need to actually account for that fact, right? And then the other answers are going to be, this is 0, right? So remember, just a little bit of algebra. Back when you're solving quadratic equations, for example, let's say x squared minus, 5x plus 4 equals 0. How you dealt with this is if it factorized, you were able to say this, and you could either say that this is 0 or this is 0, so therefore x is either 4 or x is either 1. And that was the solution to the quadratic equation. Well, this is really the same thing, right? We're just dealing with this in exactly the same way. This is a quadratic equation in sine. I've separated it out. So either the yellow bit 0 or the blue bit 0. If the yellow bit's 0, what am I solving? I'm solving when is sine theta 0. I haven't specified a range because I forgot. That's the only reason. So let's just keep the range as it is usually. And just by sketching the graph of sine here, I can see that there's 3 solutions where it's going to be 0, right? So that's 0, 180, and 360. So I'm going to get 3 solutions for the sine theta equals 0 problem there. So I'm going to write them down. So theta equals 0, or 180, or 360. Okay, and the other part, sine theta minus 1 is 0. Well, that's just sine theta equals 1. That has 1 solution. Okay, so that's going to be 90 degrees. So we have a grand total of 4 different things that can be in this range, right? Let's do one more sort of tough question, right? So let's have a quadratic in tan theta. So let's go tan squared minus 3 tan theta plus 2 equals 0, where the range is the same as before. Now, if this is true, we just want to factorize it out as before, and you can spot that this works. And if this works, then we've just broke it down into 2 problems again, right? So these quadratic trigonometric equations, you just kind of break them down into 2 simpler trig equations, right? And then I'm just going to solve each of those individually as I did before. So I won't take you through that because it's a bit easy, but I'll just tell you what the answers are that you should get. So 45, 225, then 63.4, and 243.4 degrees. So that's the 4 you're going to get. So try that one yourself. Okay, and another one. So maybe you might ask the question, what if it doesn't factorize? So let's have an example where it doesn't factorize. So sine squared plus 3 sine theta plus, I don't know, 1. Does that factorize? I guess that doesn't, hopefully. No, it doesn't. So therefore, what we want to do is just use the quadratic formula. So you should remember that, this whole thing, ax squared plus bx plus c equals 0. The quadratic formula says that this is minus b plus or minus the square root of b squared minus 4ac all over 2a. So I can just implement that in this setting. When a is 1, it's, usually simplifies a bit. But if it doesn't factorize, I'm doing a similar thing here. I'm just writing sine theta equals minus 3 plus or minus the square root of, so 9 minus 4, so that's 5 over 2. Okay, and those are my two answers. Now here, what do I get? I think one of them is actually outside the range. Okay, so if you think about that, that's minus 3 over 2 minus root 5 over 2, right? Or the other one is minus 3 over 2 plus root 5 over 2. Root 5 over 2 is about 1, right? So therefore, this answer is about minus 2.5. So what I'd be trying to solve is sine theta equals 2.5, and that can never happen because sine theta has a graph that's bounded between, minus 1 and 1, right? So at no point will we get a value that's down there at minus 2.5. So this part of the equation, we just say there's no solutions there. Now with this part, then I solve that equation. So what's this approximately? I don't know, like 1.2 or something like this. So then I'm just gonna go back and solve that problem as before. Sine theta equals 1.2, and that's sort of we've reduced the problem to a simpler problem that we already know how to do, and that's the trick. Okay, and maybe we'll do one last one. So this is they like to ask this a lot actually, so pay attention. It's when you have a quadratic, but it seems like there's different things going on here, right? So you've got a cos squared, but then you've got a sine, and it's like, how do I deal with that? Well, again, it's just something you need to have seen before to know how to do. And remember, a while back I introduced the Pythagorean identity, sine squared theta plus cos squared theta equals 1. This is something you're just gonna have to know off by heart. It's ubiquitous in mathematics. It just comes up all over the place. So therefore, if I rearrange that slightly, I get cos squared theta. That's equal to 1 minus sine squared theta. I can take that over to the other side, right? Like that. So I can write this bit as 1 minus sine squared theta. So I've got 1 minus sine squared theta plus 3 sine theta minus 2, blah, 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 blah. But that's basically a quadratic in sine theta now. So, I guess personally I would move this, multiply by -1 or whatever you think, move it over so that we have a positive coefficient in front of the squared, because that's just how I like to deal with these things. And then we have this scenario, and we have a -1, but of course that will change to a +1. I proceed as follows. So again, the problem becomes a problem we've solved already, which is why you need to sort of practice all of these. They all play into each other, and even equations like this, they'll come up in harder problems. Eventually you'll get out an equation like that, you'll want to solve it, but in the exam you need to be pretty comfortable in solving all these, and just in life in general, you never know when you're going to need to solve a trigonometric equation like this. Probably for some of you never, but you never know. It's good to it's good to know how to do it, good to practice it. Anyway, I hope these videos are providing you with an easier time dealing with mathematics problems. I know they can be difficult to understand in a classroom setting sometimes. This is what I'm trying to do here.